We're going to do section 8.2, but a second day of it, day 2, multiplying two binomials. It was supposed to go with yesterday's, but to multiply two binomials is different than what we did of just doing one monomial with a polynomial. When multiplying two binomials, we're going to do what's called the FOIL method. You'll hear it referred to most of the time. It's not a real method. It's a acronym for making it a little bit easier to remember how to do it, but it really is just the distributive property. So if you know the distributive property and you're relatively good at it, you'll be fine. So take a look at what we have here. If you don't have your handout, then write this down yourself. You have 2x plus 1, and you're multiplying it times 4x plus 3. Okay. Normally, when we did multiplying a monomial with a polynomial, we would only have one term out here. So we would just take the 2x and distribute it to the 4x and then to the 3. But now you have two different terms that have to be distributed to two different terms over here, which means you're going to have to distribute this number once, twice, and you're going to have to distribute this number once, twice. Well, if you can do the math, distributing twice and distributing twice, 2 plus 2 is 4 times that you have to distribute. So how are we going to keep track of which ones you distributed and how you do it in order? The FOIL method. First, outside, inside, last. It helps you keep a pattern, but basically it's saying you're going to multiply this 2x times the 4x. Why do we call that first? Because they're the first ones in their parentheses. 2x times 4x, 2 times 4 is 8, and we just learned about when multiplying you add exponents. If there was 1 there and 1 there, there's now 2. 1 plus 1 is 2 when you do exponents. And then you're going to take that 2x and you say, wait, I just distributed it to the 4x. I better also give a 2x over here to this 3. We don't want 3 to be lonely over here. So we're going to do that next. Maybe. And now those would be called the outside terms. Why are they the outside? They're the furthest away from each other. We've got the 2x way over here, the 3 way over here. Those are the outside terms. And that's where the O comes from. So we're done with the 2x. We did it twice. But now we have to use this 1. We have to also distribute that. Remember I said you're going to distribute the 2x twice and you're going to distribute the 1 twice. But to keep track and not have a whole bunch of arrows all over the place, we're going to send the 2x over the top and we're going to send the 1 underneath so that we can find it. 1 times 4x is 4x. And then the L stands for last. What are the last two numbers in each parentheses? The 1 and the 3. Be careful and make sure that you will continue to multiply. 1 times 3. Don't let your brain see that plus sign other than know that it's positive. 1 times 3 is 3. So when you're done distributing 4 times, you have 4 terms. The 8x squared came first, then the 6x, then the 4x, and then the 3. But we've already learned how to add and subtract polynomials, and you know that if you have any two terms that are alike, same exponent, then you're going to have to simplify those. You can't just leave it as 4 different terms. This 8x squared stays in the front. This constant of 3 stays in the back. But when you combine 6x and 4x, 6 plus 4 is 10x. And it still follows the rule of polynomials that you go from 2 to 1 to none. That's kind of it. There will be some negatives in there, and we'll have to be careful with following the distributive property, but FOIL just stands for first, outside, inside, last, but some of you might just recognize. Distribute the 2x twice, distribute the 1 twice. Add the 2 like terms when you're done. Those 2 become 10x. Now, I'm not going to give you a whole bunch of new stuff today. It's just this. We're just going to practice it. So try these, x plus 1 times x plus 3. I'm not going to change a bunch of colors for you, but we're going to do first. The x is going to have to go twice. X times x is x squared. So hopefully you did well with your exponents unit and your polynomials unit, or chapter section, because we're going to have to work on these. X times x is x squared. X times a positive 3 is plus 3x, and of course you'll always put the 3 first. The coefficient goes in front. We did the x over the top. Let's just, to show our work, do the 1 underneath plus 1x. I'm okay if you put a 1 in front of it because you're just showing your work right now. So if you put plus 1x, obviously I'm not going to do it. And then plus 1 times 3 is 3. So very careful, those of you that like to put 1 plus 3 is 4. Notice I didn't do that. Combine your like terms. You have a 3x and a 1x there. So you have x squared. If somebody gave you 3 x's and somebody else gave you 1 more x's, you would have 4 x's. X squared plus 4x plus 3. And let's try it with some negatives. Write this down. 4x minus 5 times x minus 2. Just keep track. Go slow. Use a calculator if you need to for negatives. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Now watch this. When you distribute, you're not distributing a 5. You are distributing a negative 5. Negative 5 times x is negative 5x. I'm actually going to highlight that for you. Let me use my fancy dancy highlighter. We are distributing a negative 5x. And then when you do it from the back number, a negative 5 times a negative 2 is a positive 10. You still have a pair of like terms in here, negative 8x and negative 5x. Watch your math. 4x squared, negative 8 minus 5 is negative 13. Keep the x, plus 10. Notice each time we've finished these, so far, it's not always going to be this way, but so far, every time we've finished the problem, we've had a trinomial. 1, 2, 3 terms. 1, 2, 3 terms. 1, 2, 3 terms. That's going to work as long as these are the same. If they're both x's, both y's, don't have an exponent on it. It'll happen often that you'll have trinomials left. Can you try this one on your own? See what you get. Write it down, distribute it out, see what your answer is. Okay, take a look. You distributed the x first, and then the 3. The x went twice, and you should have gotten 2x squared plus 3x. Then when you distributed the 3, you got 6x plus 9. Make sure you have 3 times 3 is 9. And you combine your two like terms right here. 3x plus 6x is 9x. Final answer, 2x squared plus 9x plus 9. Can you be that successful with a negative? Try it. Okay, let's see if you did it. Distribute the 4x and then distribute the negative 1. I did not highlight it for you. 4x squared plus 20x minus 1x. Yeah, I put a 1 in there for you, but it's in my work. It's not in my answer. Minus 5, negative 1 times 5. And when you combine your two like terms of plus 20 and minus 1, you should end up with 4x squared plus 19x minus 5. Pretty much the same thing over and over. Hope you get the hang of it. And they're going to give you an area problem. Remember when we did adding, we got a perimeter problem. But that's because when you add, you do perimeters. When you find area, you multiply. How do you find area of a rectangle? You take its base times its height. Or some of you in elementary school called it length times width. Well, look at what they're doing. They're not giving you anything new. They're saying take the length and multiply it times its width. So they wouldn't give you a word problem in the section that had nothing to do with the section. They're basically saying, find the area of this. Now, we're not going to get an answer. We're just going to get a simplified polynomial. Go ahead and multiply this together. You get 3x squared plus 9x plus 5x plus 15. And if I've done this too fast, pause it, slow it down. Simplify all that, it comes out to 3x squared plus 14x plus 15 because you combined your like terms of 9x and 5x. How does that problem look different than this one? Well, in this problem, they gave you the full length and the full width. Take a look at this problem. They gave you 4x. They broke this all up into a few different rectangles and squares. You have to find the area of this. Well, first you have to find its length. How long is this? It's 4x plus 1 long, but you can't add an x and a number, so we just call its length 4x plus 1. How wide is this? It's about 3 plus 2x, but I can't add those together. So I can just call it 3 plus 2x. Maybe you don't like the look of that. You could call it 2x plus 3. But let's see what happens when we put it together this way. All of our other problems had the variable first, but this time I went by the top to bottom. Distribute. 4x times 3 is 12x. 4x times 2x is 8x squared. 1 times 3 is 3, and 1 times 2x is 2x. You are still going to add like terms, but look at where they are this time. They're not next to each other like they have been every single time. So put your largest degree first. 8x squared is going first. Add your like terms. 12x plus 2x is 14x. And then your constant always goes last, plus 3. Sorry, that's kind of sloppy. That's my left-handed writing. 8x squared plus 14x plus 3. And that's how you distribute two binomials. Good luck.